Dave Smith here with one more flipped classroom math video for your enjoyment. 3 tips. First, you can speed up or slow down the playback if that helps you follow along. Second, you can pause anytime to catch up with your notes or think a little harder. Lastly, you could turn on the captions, which will show you my words on the screen below. Today's lesson involves finding the mean and the standard deviation when you know information about the data and you know probability information for the normal distribution. So we're going to teach this one just straight up by an example, and here it is. The factory produces sacks of potatoes with a mean mass of 5 kilograms. So they make these sacks of potatoes that have a bunch of potatoes in them, and the average of the mean of the weight is 5 kilograms. Now, here's the information you're given. If 10% of sacks are over 5 kilograms, find the standard deviation. Okay? So what I want you to do is pause the video first, sketch the normal curve, and sketch what it is that we're trying to do on that normal curve. Make some references, shade some areas, things like that. All right, here's our normal curve. Our mean is 5, and here's our 5.2 with 10% of the total area being greater than 5.2. So that is the normal curve sketch of our situation. Now we're being asked to find the standard deviation. So pause the video, think for a minute what a first step might be. So our first step is to standardize this normal distribution. Remember, it's not a standard normal distribution with these numbers. So we're going to standardize it. We still don't know what sigma is, so we're going to have a sigma in our answer. Go ahead, pause the video, take a look at that formula, and do that work. Okay, so what I did is I just plugged in my x, which is my a value on the horizontal axis, subtracted my mu over sigma, so I get 5.2 minus 5, or 0.2 over sigma. So that's the z. Now, we're requiring that z fulfill a certain condition, because we know that this is 0.1%. So there's 2 steps to write there. Pause the video and see what you get. Okay, so what I did is that I wrote here that we require the probability for z being 0.1 is greater, or z being greater than 0.1 is 0.2 over sigma. So remember, we always calculate them to the left. So I just switched it z less than 0.9. That's 1 minus 0.1. And again, 0.2 over sigma. Now, we still can't figure out what sigma is, but since we standardize this normal distribution, we can find out what the probability is for this statement. So go ahead, pause your video, do an inverse standard normal distribution to find this probability, and then we're going to finish this problem. All right, so now we just found what this probability is. In other words, what is the probability that a random point in our distribution will fall in this range, which is 90%, which is 90% is less than 5.2. So I put that in my calculator. Remember, we standardized. So with that, our mu is 0 and our standard deviation is 1. So we standardized it, and this solves for the value. And now, check this out. We can set that value equal to 1.28155 equals 0.2 over sigma, because that's what this was equal to. So we figured out what that was, got that number. Now we set that number equal to 0.2 over sigma, and we can solve for sigma. So before I turn you loose on that, you might be wondering, why am I carrying so many extra numbers in here? I want my number to be accurate. I want my solution to be accurate for my sigma. So I'm carrying like 6 sig figs. I will round to 3 when I'm done. So pause the video, find your sigma. All right, so here we go. My standard deviation, my sigma, is 0.156. Now, you're going to see other problems. What they might do is give you the standard deviation and ask you to find the mean. The process is similar. To do these, you're going to have to standardize your normal distribution. So remember this little trick. Actually, it was on the last board. X minus mu over sigma. Okay, so we're going to do one more complex problem where you actually have to find both mu and sigma at the same time, both the mean and the standard deviation at the same time. Fortunately, this is doable. It just has a little extra complexity. You end up solving 2 equations together. So here's our situation. There are manufactured ball bearings and they get rejected if the diameter is greater than 2.4 centimeters or if it's less than 1.8 centimeters. Those ball bearings have to be within that range, otherwise they won't work in their intended use. So you're given some additional information. 5.5% of all ball bearings are too big and 8.1% are too small. Here's your prompt. Find mu and sigma. Find your mean and your standard deviation. So articulating this problem looks like that. We don't know these things, so we have to find them. So there's a couple equations that you can write right now. Okay, so here are your first steps. We're just articulating the two boundaries that we have. So the probability that the bearing size is going to be less than 1.8 centimeters is 0.081. That's this 8.1% that they're too small. Same thing for the too big. Probability that x is greater than or equal to 2.4, that's 0.055. Now, you can calculate the z value for this using your inverse standard normal deviation calculation on your calculator. So go ahead, pause the video and do that. Let's find those answers. Okay, so running that through the inverse standard deviation calculation on the calculator, I end up with my a value of minus 1.41 for the less than, and I wind up with a value of 1.6. All right, so now we have our a values. We can use those in the standardization equation, x minus mu over sigma equation, in two places, and we can find our values for sigma and for mu. So go ahead, pause the video and try one of those. Okay, so what I did is I used my standardization equation. I got my a value, I put that out here, and then I have my x, which I know, that's the 1.8, minus mu, that's not known, and sigma, not known. So what I'm going to do, because it's easiest, is I'm just going to solve this equation for sigma. So I just switch these around, and now I have 1.8 minus mu over minus 1.41 is sigma. So now what I'm going to do is solve that second equation, which I erased here, but you have in your notes. I solved that second equation also for sigma. So go ahead and pause the video and do just that. So I just plugged that in over here. I used my a value from that second equation, 1.6. And that is 2.4, that is this measurement, that's our bigger measurement, minus mu over sigma. I solve for sigma, and I have this equation. Now we have these two equations, and we can use them in a certain way to solve for mu. I want you to think real hard about that. Pause the video, and go ahead and do that, solve for mu. Okay, so I just transferred everything up here. I have my two equations, solve for sigma. So now if they both equal sigma, then they equal each other. Then we have one equation with one variable and we can solve that. The alternative, I'm going to do this algebraically, but you could also put these into your calculator and find the point of intersection, and that would also give you your solution. In fact, that's a better way in that it's error-free as long as you enter your equations correctly. These are linear, so there's no curves, it's going to be straight lines. And they're going to meet somewhere, and that's going to give you your mu and your sigma. Okay, so what I did is I set my two equations equal to each other. Now the quickest way to deal with two fractions equal to each other is cross multiply. So I got, let's see, I did this cross here, which gives me this side, and then I did that cross there, which gives me that side. Now I'm just combining like terms and dividing through to solve for mu. So I got this step, and then finally mu is 2.08. Now, we haven't found sigma yet. So pause the video, do a little critical thinking step, go ahead and then find sigma. So hopefully you just realized that once you know mu, you can use either one of these equations, plug mu in, and then get your sigma. So I just used this equation here, I did my plug-in step, I did my math, and I've got sigma is 2.00, and then our mu is 2.08. So a few more steps, but very doable. All right, now that you've watched the video, take a minute and jot down any remaining questions so you can bring them to our next class. Also remember, you can watch the video again. Maybe that will deepen your understanding. If you like the video, please click like and subscribe.